This is central Kerala today. You can see the Vembanad Lake, the Western Ghats, and all the rivers emptying into the sea. And this is how the region used to look around 10,000 years ago. Oh wait, where'd the Vembanad Lake go? That's right, it hadn't been formed at that time. Hello everyone. So in the past video we had looked at how different the earth would have looked when humans were moving out of Africa 50,000 years ago, and how some of the regions that we are used to today, like the Sahara or other parts of the world, would have looked very different due to the different climate cycles, right? In this video I again want to focus on climate cycles for a little bit. Although the Earth's climate has cycled many times in the past, I want to focus particularly in the last 400,000 or 4 lakh years or so. Now, the reason we are interested in these past 300,000 or 400,000 years is because the continents would have reached their present positions and would have been there for a pretty decent amount of time, and the climatic features or patterns that we are used to, like the Indian summer monsoon, would have been established. They would have increased or decreased in intensity, or they would have cycled, and hence the title of this video, Climate Cycles, but they would have become established. Now, why does a climate cycle? I'll link a video in the description which explains this much more thoroughly, but for a very brief explanation, this has to do with the change in the orbital parameters of the Earth. That is, the way the Earth rotates in its own axis and the way the Earth revolves around the Sun. Changes in these orbital parameters affect the solar radiation which reaches the Earth's surface. Now the amount of solar radiation that we receive is one of the biggest driving forces in the Earth's climate. This affects if the amount of snow that falls during every winter gets completely melted away in the summer, and thus not allowing for ice caps to form, or if the amount of solar radiation is a little less in the summer such that it allows the snow to keep falling, thus forming ice caps, and if it happens over a large extent, ice sheets and glaciers. But enough about the ice sheets. Let's talk about the monsoon, because that's a climatic pattern that I'm very interested in. Now, the amount of rain that a region receives is highly dependent on the amount of moisture that the air about it can hold. And as a rule, warmer air generally holds more moisture. Now, it's also dependent on factors like how close the nearest sea is, or what the surface temperature of the ocean is, and all of that. But generally, as a rule, if for a large period of time, let's say hundreds of years, you have warmer temperatures over a region, that region will get more rain. And this is what we find. The monsoon system, which affects most of India and parts of Africa, goes through cycles roughly every 20,000 years or so. If you remember what I showed in the last video about the Green Sahara, that was due to this cycle. And right now, or rather for the past few hundred years, we are at the bottom of the cycle. 6,000 to 10,000 years ago, we were at the top of the cycle. That is, the intensity of the monsoon and the amount of rain we received was the highest. And that's why we had a phenomenon such as the Green Sahara. How do we know all of this? Well, in the last video, again, I had showed how we have evidence of this from Africa, such as cave drawings and satellite imagery showing paleo channels found in the Sahara Desert, right? I want to talk about something interesting from Kerala as well. Now, if you look at Kerala is a region which is blessed with rain. We receive like 3,000 mm of rain every year, right? And now imagine 50 to 100% more rain. The general green nature of Kerala and the entire Western Ghats is due to the existing amount of rain that we receive, and about the reason why it looks different from, let's say, the Deccan Plateau and parts of interior Tamil Nadu. Now, if we had nearly double the rain, how would Kerala have looked? Our best guess is that the whole of Kerala was heavily forested right up to the coastal edge, and a lot of the lake systems that we know today, like those at Vembanad or Ashtamudi, did not exist. We have evidence of this from fossilized tree trunk samples found from a lot of places in central Kerala, which are indicative of much higher rainfall and vegetation. So again, why care about all of this? All of this happened like tens of thousands of years ago, right? Well, human civilization, that is agricultural civilization of the particular kind that we have built up over the past 10,000 years, is dependent on a particular set of climatic conditions which have been available only for the past 10,000 years. Glacial Earth is not really suitable for setting up an agricultural civilization for a few reasons. Firstly, ice sheets take up a lot of land. It's 10% today, but at the height of the glacial maximum, it was around 25% or so. And secondly, the land immediately south of the ice sheet called tundra is not very productive land. This long belt of land which stretches all around central Eurasia, which is steppe today, would have been tundra and not very productive. And thirdly, like we said before, the amount of rain falling on a region is proportional to the warmth of the air above it. And during a glacial maximum, the air is not very warm, and hence there won't be much rain. And without rain, agriculture is kind of difficult to get started. The human race has been very lucky in that we found a particular set of excellent climatic conditions to establish agriculture around 30 or 40,000 years after we left Africa. Lucky in that we came in the sweet spot between two cycles. One which restricted the ice sheets to the northern latitudes, to the extreme north latitudes, and second, which increased the amount of rain falling in with the general monsoon system, thus allowing plenty of water in rivers like the Nile, the Tigris, the Euphrates, the Ganga, the Yamuna, the Indus, all of these rivers. A little too lucky, I would say. The next part of this video is from a book which I read and really liked. It's by this author William F. Bradyman. It's called Loves, Plagues and Petroleum. So just like the amount of the types of visible indicators that we have, like sea level or the amount of ice sheets, we also have other invisible indicators which also cycle along with the climate. The amount of greenhouse gases in the Earth's atmosphere, like CO2 or methane. Now, we have been tracking the amount of greenhouse gases on the atmosphere using instruments during the past 100 years or so. But we also have ways of tracking how it was even hundreds of thousands of years into the past, using one of the coolest things ever, ice cores from Antarctica. So the basic premise is this: when ice crystals form, the water molecules also trap little bubbles of air from the air surrounding it, and by extracting an entire ice core, which goes for hundreds of thousands or even like 1 million years, and extracting the air from that, you can get a snapshot or the composition of what gases were trapped in those bubbles at that particular point of time. Again, I'll link a video in the description. Now coming back to the book, what the author has found out is that the amount of two greenhouse gases in the atmosphere, CO2 and methane, has a very close relationship with the amount of solar radiation falling on the Earth, called the insolence. So usually when the insolence is high, the amount of CO2 and methane is also high, and when insolence is low, CO2 and methane also go down. And this relationship has stayed the same. It has stayed very close over the past all cycles, except this one, the one in which we are currently. What the author found was that in this cycle, the insolence was at the maximum around 6,000 to 7,000 years ago, and the CO2 and methane was also the highest at that point of time. And then insolence started decreasing. In fact, right now, we are at a point in the Earth's history when insolence is at a low point in the cycle, but CO2 and methane has not kept pace with that cycle and gone down. Now again, and in fact it has actually increased. Now again, when we say increase, this is a very, very small increase. We're talking about like 20 ppm, 20 particles per million increase over the past 7,000 or 7,700 years or so. What could be the reason for this? The reason the author believes is human activity, one particular human activity, agriculture. What the author says is that agriculture has been racing, and here I want to stress again, very, very slowly racing the amount of greenhouse gases in the Earth's atmosphere over the past 6,000 to 7,000 years. This happens through two ways. One, when forests are cleared for expanding agriculture, as has happened throughout history, it emits CO2 when the forests are burnt or when the soil is disturbed. And second, flooded paddy cultivation, like what is practiced in China, parts of Southeast Asia, parts of India, including Kerala, releases methane. This, the author says, has been increasing the amount of CO2 and methane on the Earth's atmosphere over the past 7,000 years. Now, when I read this, I was very interested. Human impact on the environment seems like a very modern industrial phenomenon, right? But here, unknowingly, humans have been maintaining one climatic factor conducive to agriculture by the very aspect of expanding farming. But, and there's a very big but, more is not necessarily better. The amount of greenhouse gases that are currently being emitted in the atmosphere over the past 100 or 150 years is very bad for agriculture, but that's not the topic for this video. Now, before ending this video, I want to say one more thing. This research, while great, seems to me like the kind of thing that would make it easy for climate change deniers to kind of lessen what is going on right now by saying, look, humans have been emitting in the past as well. So greenhouse gas emissions are just humans being humans and we should continue to emit in the future. That's a big fat lie. No. The process through which millions of farmers would have slowly emitted very, very small proportions of greenhouse gases over thousands of years is not at all similar to what has been going on in the world for the past 100 or 150 years, ideologically or process-wise. But that's a topic for another video. So if there's a single takeaway from this video, let it be this. Don't think about the climate as some eternal unchanging thing which has started changing only in the past 100 or 150 years, and farming as this natural activity that has been practiced since time immemorial. It is a specific, very specific practice, human practice, that is arisen due to specific historic climatic conditions. Field after paddy field is not natural, or at least it's not the only kind of natural there is. It's a different kind of nature. Our impact on the climate and environment has been going on longer than we think. Thank you.